Things to look for, belt, is each position, the bushings inside could be creating an issue with the vibration. I normally, whenever there's a vibration, if I can feel a vibration in the unit, your hands are your best teacher. I usually just put my hand on the unit. It's the first thing I'm going to do. If I feel a vibration someplace inside of it, I'm going to try and isolate what the source of the vibration is. I'll grab each vessel position, every one of the shafts, and I'll put my finger on top of the shaft and feel if there's a difference between shaft to shaft. Sometimes inside the internal workings, maybe they need to be lubed. Inside there could be some gumming up of the unit itself. I'll pull one of them out and we'll look at what the bushings look like inside so you guys understand what it looks like inside. But maybe that needs to be lubed. Maybe again, like I said, the belt, maybe the belt needs to be lubed. Maybe the belt needs to be replaced. Maybe it needs to be cleaned. It could be a lot of buildup. I've seen a lot of places where there's a lot of gunk and buildup of the residue of a belt wrapped around, and as it's going around, it's causing some sympathetic vibration, which actually, the faster you spin the RPM up, the more pronounced the vibration becomes on the unit, because it's going around faster and faster and hitting that chunk of debris that may be in there. And again, once you eliminate the unit itself, you need to start looking at the surrounding environment. There may be issues going on. Like I said, construction on another floor, an air conditioning unit cycling on and off. Maybe it's a production plant. Maybe, I don't know, maybe it's 3:30 in the afternoon and it's time for everybody to go home. And there's people marching out the door and they're causing a vibration. There could be any number of reasons causing vibration in the unit that you need to check the surrounding environment and try to eliminate. And I'm saying this because I don't know if any of you do chemical testing on the units. We do here. Most of our technicians are trained to do that. But if you fail a PVT test, one of the first things I start looking at is vibration. That's normally what, well, the current lot notwithstanding, that's normally what you'll end up isolating your problem down to. It's something to do with the vibration of the unit, whether it's a mechanical defect with the unit causing this vibration, or an OOT, an out of tolerance, or it's something to do with the environmental vibration. Something you need to at least take a good serious look at. Timers, I don't think we need to go into that very long. Everybody has different types of timers. We actually employ a 3-position timer that we use. It helps out in a lot of different ways. Basic 3-position timer. 1, 2, and 3. Press 1, press 2, or press 3, different rows. You need to use a timer to take any kind of timing specifications. We have the MQ1 and the MQ2 tests that are required on each one of the bats that we do. If any of you do the auto samplers, there's some timing tests involved with the auto sampler. In fact, almost every one of the units that we manufacture has some type of timing test that's involved with it. The easy fill notwithstanding. I don't know if anybody here qualifies the easy fill, the degassing unit.
Yeah.
Yes, yeah, there's no timing on that. But there is a lot of other measurements that we'll do, and we're going to talk about that on Friday. But yes, so the timer, yeah, just a timer. Has to be plus or minus 2%, so the tolerance for a 30-minute run. If you do PVTs, all that translates into, if you're doing a performance verification test, is you can start your pulls at 30 seconds before the 30 minutes ends, and up to 36 seconds past the 30-minute run. If you guys are doing PVTs. Digital level, digital protractor. You guys use this? Everybody? You? No? You have, so far you haven't noticed any of our tools. Do you have any of these?
No.
You going to purchase these?
Yes.
You can use any that you want. You can get them from anywhere. You can get them from us or you can get them from anybody else. I, again, promote Distek, buy from us. We make money, that's fine, but you don't necessarily have to, you need to have validated tools in order to use, but you don't have to necessarily go through us. In fact, I know some distributors that actually use the QA2 station from Agilent to make their measurements. So it is what it is. Easy, simply on and off button, turns it on. The numbers come up. When you set it down on a surface, you can zero it out. And it'll zero it out at 0. And that should give you you've zeroed it out on the plane that you're going to be testing. Typically what I'll do is if I'm testing sideways, I'll zero it out. And then I can make all my measurements from side to side, on either side of the shaft, on either side of the vessel. If I'm going to go front to back, because everything can change, everything's relative to what you're testing, I usually zero it out front to back also. And now I'll make my measurements up on the shaft or inside the vessel, front to back, or close to that. As I said before, when using this, you're only required to do it at 90 degrees. So no matter what, if you're on a shaft, if this is your shaft, you need to do a reading at night, one reading, and another reading has to be 90 degrees off of it. And what that means is simply this. If I'm going to take a reading here on the shaft, I'm going to take one right here, and the next one I take, it has to be 90 degrees away from that one. So I'm going to take another reading over here, at this right here. And again, it has to be 89.5 plus or minus 0.5. I'm sorry, 90 degrees plus or minus 0.5. So it has to be 80. It has to be 89.5 or better in order to have a passing range. Same thing happens when you're inside the vessel. I had the vessel over here before, but simply goes down inside of it, and you're against the wall of the vessel, and it's 90 degrees. Take one reading here. You're going to take the next reading, has to be this way, or over on this side, this way. Doesn't matter how you read it. But again, has to have the same passing specification. You're checking verticality to 90 degrees. 90 degrees is straight up and down. If there's an issue with it being straight up and down, as I was talking about before, the most likely culprit is the leveling of the unit. If it's not, if you're getting a range to say below 89.5, you've got 89.4, 89.3, 2 or 3 positions, more than likely you have a leveling issue. You should check the level of the unit. I would just go ahead and check it and adjust it again. Get it as good, if you have to, instead of using, I usually use a bubble level to do my XY measurement, but feel free to use this. And if this is not close to 0, if you're not at 0 when it's on top of there, if you go to the bench that it's attached to, and you can 0 it out, and then you put it up on the vessel plate, and it's not at 0, adjust the level of the unit and get it to 0. Because then it'll be exactly the same exact levelness of the bench that it's attached to. That we have a better and greater chance of passing the verticality test when you get ready to perform them. That's the only thing I can say about that. There's nothing that's going to cause you to have a fail on this. You can't. I mean, unless one position's broken and the rest of them are not. You might have a single position that's out of specification. But you're not going to ever have all of them not reading right. That's a leveling issue. So it shouldn't be too difficult to figure it out.
The problem with that protractor, if you keep the power button
Yes.
longer than 2 seconds, and you go in calibration mode, and
then it goes
throw out
in
the
again.
whole calibration.
Yep.
This is so.
This is the paddle and basket shaft verticality. And here's the vessel verticality. This is for ASTM. Digital level sleeve I talked with you about, and I said it's useful on varying vessels. Mainly what we use it for. Multimeter, you all know how to use a multimeter? Right? Everybody knows how to use this? I don't think I need to go into it. It's simply a matter, I'm an electrician by nature, so this positive and negative, you're checking for voltage. If you get confused on what to set it for, usually there's a sine wave. So as I've had a technician, we had a female technician here that called it V squiggly, but because it's a squiggly line, I guess. But it's the sine wave. That's all you need to know to set it for. That's all we use it. There's only 2 things we use other than troubleshooting. If you're not an electrician by nature, if you don't do any heavy electronics, your voltage is the sine wave. That's what we're setting it for. That's when you're checking your AC voltage coming out of the wall or into a cable. That's what we're checking for, to make sure that it's plus or minus either 115 here stateside or 220 in most of the countries outside of the United States.
Yeah, and 240.
240. Well, it depends on what the environment inside the lab is. I say 220, 230, depending on what lab we have. There are some 220, 230s here in the United States. I know overseas, some of the places that I've been to have been 240, 50 hertz, I believe it is, right? Yeah. And if you have to do any resistance readings, it's the horseshoe sign on here, which is the ohm sign. Looks like a little horseshoe on top of there. That's simply a matter of reading the resistance of making sure that a fuse is open or closed, or checking a switch. It's in our 4300 documentation, the auto sampler. You're specifically required to actually check a switch out. That's part of the qualification. But again, it's not very hard to learn how to use a meter. I think that's it. Any questions on any of it? Now's your time to ask. No? Everybody good? It's coming up on 4 o'clock. Why don't we call it a day? We'll meet back here tomorrow at 9 o'clock in the morning. Well, 8:45. That way you can get a coffee.